flight that was in 26 years ago in 1992 that I went in space. I went 143 times around the Earth for a scientific mission where we did measurements in our atmosphere and also auroras and so on, the sun. So, but now we go to look more to the future, what's going on in the future. And so now there's a lot of activity for Mars, so that is the next frontier. And the first thing that I will show you is a picture that I took the 1st of July, in the middle of the night. So it's not a good picture. I just took it with my iPhone, and it was full moon. I was very happy to see this full moon, but there was a star just beneath it. But it's not a star, it's a planet, and it's actually, it was Mars. And so for me that was like a symbol that on one side you have the moon, that nearly 50 years ago, the people went to the moon for the first time. You remember Neil Armstrong, a small step for him, but a giant leap for mankind. It was expanding the human presence in our universe, so we went a little bit farther. But it's normal that the humanity, that they don't stop there. So now there are other projects, and the next projects that you can have, the next frontier that you can have is Mars. And so there are already quite some preparations for Mars. We'll speak a lot of it, and we want to give you some information about what is going on, and perhaps when you have the opportunity to go to space, then to Mars. Why did we select Mars? Why is it Mars that is interesting? Well, it's the next tangible frontier for this expanding human presence. So that after the moon, the next step that you can do is go to Mars. And Mars is, we feel now that it is an achievable goal. When we had the project to Apollo to the moon, after that project, we thought, the scientists, the technicians, and myself also, we thought that the visit of Mars would happen 10-15 years later. And NASA as well started a program for a mission to Mars. It started even to do studies and even started to build some hardware. But soon they realized that it was too early, that the technology was not advanced, sufficient advanced to do that now. And then they stopped that project and they started to build the shuttle program. And I had the opportunity to fly once with this shuttle as well. So, but now the shuttle has finished, and they speak again about going to Mars. Mars is what we call our sister planet. In the origin of our solar system, Mars and the Earth have their origin just when this solar system was starting, and 4.5 billion years ago. And from the beginning, Mars and our Earth were nearly the same. They have followed the same cycle of activities what was going on for the first billion years. At 3.5 billion years ago, then we got the first, we think that then we got the first signs of life on our Earth. And then we saw also that the Mars we don't know if we thought that they had all the possibilities to get life as well, but we don't know it, and we still don't know it. And that is one of the questions that we ask now. Is there life, some form of life, some microbiological life? Is that there still available on Mars, or is it not there? And if it's not there, then we want to know why it's not there. For a mission to Mars, that is, we consider that as a very huge challenge. It's very difficult. It's marvelous that they try to do, but we are convinced that it can be done. And there is still a big risk. And like for Apollo, the mission to the moon, NASA is calculating the risk, has formulas to calculate the risk, and they could say afterwards that the risk is about 5% that we have a mission that will not work. To go into Mars will be much more difficult, and if they can come to a risk less than 10%, they will be very, very happy. This is sure that there are the technologies that still has to be developed. It's achievable, but we are not yet there. There are quite some things that we still don't know, but finally, if we look compared to the Apollo mission, when President Kennedy took the engagement to send Americans to the moon and bring them safe back to the ground, the Americans have not yet one person in space. So, and he took that commitment to do that. So there were also a lot of things that they didn't know yet. But he told that they would do it before the end of the 60s, and finally they could do it. A question that you can ask, why do we send humans to Mars in such a dangerous environment? We could do it by robots. Robotics is going fast these days, so we find it everywhere. Why not using only robots? But we have learned that the added value by having astronauts on board is tremendous, that they can help a lot forward. If we see, for example, the robot Curiosity, who is now since 2012 on Mars and turning around, finally the distance that he traveled is about 50 kilometers, not more. So that is, well, if they have humans on board, they hope that they can go earlier, farther away from the point where they landed. Going to Mars is a big different thing than going to the moon. We say the astronauts going to the moon, we call that backpackers, because they went there, they had their oxygen, their food, their water, their energy, they all took it with them. They didn't need anything from the moon to survive. Going to Mars, we will see that because it's such a long time, that a mission to Mars will be about 3 years, they cannot take all the food and all the things they need for that time. So they will have to live from what they can grow and what they can find on the location where they're coming. So that's a big, very different game than what it is to go to the moon. Some characteristics of Mars. The composition first, the composition of the soil is similar to what we have on Earth. It is a mission, a lander, they call it, is an instrument that is going down and staying up one place. There's the Phoenix. This instrument made an analysis of the soil, and they could say that the constitution of the soil was quite similar to what we have here on Earth. Very important is that if we have to cultivate things on board on the planet for their living, then we know already that products that we know here probably will be able to produce that on Mars as well. And perhaps there are some people on the who have seen the movie The Martian, and it's an astronaut who has to survive on Mars, and what is he doing? He's cultivating potatoes. So, and effectively, potatoes is one of the products that they considered that could be grown on Mars. So it was, this film had been made with the help of NASA, and probably NASA has said, well, that is some product that you could try to show in the film, that he's surviving with growing potatoes. Mars has also water, and we consider that water is one of the essential elements to have life, that we hardly can have no life with what we know here on our Earth, that we can have life if there is no water. We know that there is a lot of water on Mars, but if you see the pictures of Mars, it's very dry, it's like a desert. There's nothing but growing there, and you cannot have water on the surface because the atmospheric pressure, the Mars has an atmosphere, but the atmospheric pressure is 6 to 7 millibar. And so if there would be water at the surface, it would be volatile easily, so it's you cannot have it. But they think that there is a lot of water. They know already that there is surely water on the poles, where in the frozen form. There is a permafrost where there is also water in, but they think there is also fluid water somewhere under the ground. And so if they go to Mars, they have to find this place if they want to have water. If they cannot find that water direct, or cannot be close to that water, then they will have to produce it in some way or another. Mars has no magnetosphere. You know that our Earth is a dipole. You have North Pole, the South Pole, and you have the compass that are always going in the direction of the north. So, and on Mars, you don't have that. There is some magnetism at certain places, but there is no magnetic field and then no magnetosphere. And that is very important as well, because we here on Earth are protected against radiation, the galactic cosmic radiation, and the heavy particles from the sun are dangerous for people, for astronauts, and so that's surely a big problem. Here on Earth, the magnetosphere and our atmosphere are blocking this radiation, and we are protected. They have even a third protection, that's the belts from Van Allen, that also capture some heavy particles in the air. So that you don't have that on Mars. Thus, there is a problem with the radiation. They have to be very careful. Surely the galactic cosmic radiation, they have for the moment still no way to stop this, and they can be very dangerous. But this radiation can damage the DNA from the astronauts, and can be the cause for cancer and so forth. So they have an acute danger, and also danger for long duration. So that is a problem that they still have to solve before they can send people to Mars. Mars has an orbit with an inclination compared to the equator, just like the Earth. It's nearly the same. It's 23.44 for the Earth, and it's 19 for Mars. So this is the inclination that makes that on Mars we also have seasons, just seasons like we have here. But a year of Mars is 687 days instead of the 365. So that means that it's nearly one tour that Mars is doing around the Sun, while the Earth is doing 2 tours. So that is a difference, so that their seasons are twice as long than what they are here on Earth. The day is also smallly different from Belgium. The Mars is also turning around its axis, so that you have day and night. But the day and night, so the day on Mars is nearly 40 minutes, 39 to 40 minutes more than what we have here. So there's just also day, night, somewhat the same, but with a difference of 40 minutes every day. Such a day, Mars, they call it a sol. So what we still call the day here is on Mars a sol. And then Mars is farther away from the Sun. The Earth is at 1 astronomical unit from the Sun. Mars is at 1.5 orbit astronomical units from the Sun, so it's farther away, receives less radiation, and it's only 44% of the radiation. So again, something that is important. If we want to colonize Mars, that we can have powered by the Sun, by solar cells, but we need twice the amount than what we have here on Earth. There are already quite some missions that have been done to Mars. The first who tried to go to Mars with a satellite were the Russians. It was already in 1961, so very early in the history of the space exploration. And so, but these first missions didn't work. And the first time that they have that there was a satellite that went close to Mars was the Mariner 4, even Mariner 1, Mariner 2 and Mariner 3 didn't work, so the fourth they could come closer to Mars and have the first pictures of the planet itself. So we have 4 types of experiments that were sent to Mars. We have the flybys, like this Mariner, but then later in 1971 they had the first satellite around Mars, and that was with the Mariner 9 experiment. For me, is that something very special, because I had the opportunity to do a postdoctorate in the United States. That was in Boulder, Colorado, and the University of Boulder, Colorado, and they had an experiment on board of this Mariner 9, and the operational center for the scientists was in Boulder as well in the university. So we could see everything, and I contributed to that project as well. And you see what was the evolution. At a certain moment, they could bring the Mariner 9 in an orbit around the Mars, but when they looked to the ground, they couldn't see anything, because it was just a dust storm. And then on Mars you can have heavy dust storms. And so they couldn't see the ground. And then the only thing that they could do was wait till the dust was going down, and then effectively 2 months later the dust was gone, and then they had marvelous pictures for the first time. They had marvelous pictures of the soil of Mars. Since then, there are quite some number of satellites that have been sent around Mars. It is from surely the Americans, for NASA, from also from the Soviet Union was that still at that moment, and then they know there is also one from India, that a satellite that is turning around Mars. So there are quite some. Also from Europe there is one. So there are quite some number of experiments that have been done. Mars is very attractive in the different space agencies. The next instruments that they went were landers, the instruments that they put down on Mars and that was doing their experiments. It was first Viking 1 and Viking 2. The major project for this Vikings was to find if there was life on board on Mars. But they couldn't detect anything at all. It doesn't mean that there is no one. They were just probably measuring on the wrong place. Then we have the Phoenix, also such a lander. And now there is the last one that is the InSight. And InSight was launched in May of this year and will arrive on Mars in November. And this lander, this instrument, is doing measurements, seismographic measurements. They will drill holes in the ground, so 7 meters deep, and so on. We'll have more information of the geology of Mars. The next group of instruments that they have, they are the rovers. That was first, that probably you remember, a small, it was like a toy auto that was going on Mars, and so it worked only for the 3 months, and but it was the first rover. Then they had two Spirit and Opportunity. They were already bigger, and Spirit didn't work so just did the mission like it was foreseen, but Opportunity is still operational. That was launched in 2010, so and it's still operational. The Opportunity, they still have pictures for that from that instrument. And then we have Curiosity, that is a bigger rover on Mars, and surely every day we can see the pictures that are taken are marvelous. What they have as what they can see from Mars since we have these rovers and the satellites is you cannot compare it to what we saw. Even when I was still studying, what we had from Mars was really very fluid, nothing. You see, this is just some pictures that were taken. The first picture of Mars was taken by Christian Huygens with a telescope, and it's just nothing that you can see, and that was for a long time. In 1988, an Italian scientist, he thought that he saw channels on Mars. And immediately he thought, if there are channels, there must have been intelligent people there that can build these channels. Afterwards, they have seen that it's not true. It's only so when they have a telescope in 60s was still nothing clear that they can see on them. And then with the Hubble, we saw a little bit more. And it's only when we have the satellites now that we have nice pictures of Mars. It's so we have so many pictures and so many information that we already have a map of Mars. And we see that you see here, well, the colors are artificial, and so the blue doesn't mean that it is sea. It's just a lower land because there's no water anywhere. The surface of Mars is not nearly the same surface as what we have here of the Earth, of the land on our Earth. So you know that on the Earth we have 70% oceans. So if we take that away, what is left over is nearly as big as what we have on Mars, because there is no sea. What they saw as spectacular things is here these mountains. There is a mountain, the Olympus Mons. This is 22 kilometers high. So if you compare it with the highest mountain here on our Earth, is 8 kilometers, 8.6 kilometers, so only 2.5 times less than what this mountain is on Mars. Mars, that is still much smaller than our Earth. The diameter of Mars is 6,000 kilometers, while from the Earth it's 12,000 kilometers. So the size is much smaller, but we have mountains that are very, very high. And we saw also that was detected by Marina 9, that was a big canyon, about 4,000 kilometers long and 400 kilometers large and 7 kilometers deep. And probably they think that this was formed in the beginning year of forming the planet. If you compare that with the biggest canyon that we have on Earth, that's the Grand Canyon, it's only 400 kilometers long, so it's 10 times smaller than what we have here on Earth. It's very special. Then we have here a big deep dip in the surface. Probably is that also from a collision with an asteroid that has created in some way this hole in it. For the rest, we see that the higher regions, there is a lot of craters for impact from meteorites and asteroids. And while in the lower part, you don't have that. So that is probable there was water at that place, so that made probably that there were less impacts there than on the solid ground. Let's see now what the mission to Mars looked like. You see here, it's just schematic, so that's our solar system. We have here the Sun, we have the Earth that's going around the Sun in 365 days, and here Mars in 687 days. But that means that nearly 2 years, and so that means that sometimes they are both on the same side of the Sun, and a year later, one is at this side and the other one is at the other side. When this situation, when the Earth is here and Mars is there on the other side, there's no way to go there. That's much too difficult. You need a lot of time and also energy to get there. So if we have only a window every 27 months, a window of about 2 months that we can go easily from Earth to Mars. So that we show here. So you can go from Earth to Mars. So that is, well, they have here 260 days. That is changing every day because the distances are changing. The orbit of Mars and the Earth are not perfect circles. They are there's an eccentricity, and so that makes that this is always different. The calculation they have done here, that was 259 days to go from the Earth to Mars. It's so that they need energy just to get the speed and bring it on an orbit that is tangent to Mars. But for the rest of the mission, they don't use energy. They just flying like the moon. But when they are there at 260 days, they cannot come back immediately to the Earth. They have to wait 455 days, a year and a half, before they can come back to the Earth in about the same 7-8 months. That makes it very difficult, and so that once that they're going away, you have to wait 2 years before that you can send another one. That is one of the big problems and the big dangers that's why you have to stay such a long time. There is they are working on rockets that give more energy, so that they can go from Earth to Mars in 90 days, and then they just have 10 days that they can stay there, and then they have to come back, and can come back in 90 days as well. That would be a mission of 190 days. That you would think is much easier to do, but surely the NASA doesn't want that, because that for the effort they had to do to go to Mars, to have all this trajectory, and just go to set your foot on the ground and come back, that is a little bit too much. Here there's another orbit that they showed us here, where they use more energy and they can go, for example, in 120 days, but then they have to wait 600 days before they can come back. And so the total is a little bit less than what they have with the other launch, but they have to stay there 600 days, so much longer. So that makes it surely difficult. Now, what existed already, they are working on these projects, but what existed already for the moment. Surely from the side of NASA, who want to have the lead in this, there's a project that they cannot do alone. They have to do it with other agencies, and all the agencies of the world. But they are building already quite some hardware, that you will see. See, that is a copy of the Orion. Orion is the module that they are building to go back to the moon and then to go to Mars as well. You see, it's no more a shuttle. To go to Mars, they realized that they don't need wings. So it's again a module that is quite similar to what they used for Apollo to go to the moon, and what the Russians are using now to go to the space station and coming back from the space station. So that is a special form that it has a stability in the air when it is coming back in the atmosphere. This Orion, they can have 4 people on board, or even sometimes 6 people. So that is important to notice that as well. And it has a heat shield to come back to the Earth, to come back with a very high speed, and then it's by drag. It is the speed is reduced by drag to the Earth, and they have already done in 2014 a first test where they brought such a module till 5,000 kilometers high, and then dropped it, and it came in the atmosphere with a speed that is higher than what they had before, even for the missions to the moon. And just to test if this heat shield is sufficient for a mission to Mars. So this Orion is already built, and they're also building the rockets that they need for that. The rockets, probably some between you have already seen the copy of the Saturnus rocket in the United States. It was in Florida, in Huntsville, you could see, and you still can see that there, how big this is. Now, this the rocket that they are building to go to Mars is 20 to 30% bigger than the rocket that they used to go to the moon. So that is very, very, very big. See here just a diagram. You see that the height is 102 meters. So and the diameter is 8.4 meters. And then they will still use the two solid rocket boosters like what they had to launch the shuttle as well. And I have here a picture of such a solid rocket booster, how big it is. There is no people around, but you can see this ladder here, the height that this is, and how big such a rocket is. That's the the most powerful rockets that exist for the moment. It's the rockets that they have on, with these boosters. This is another picture of the Orion, and with the service module that is here fixed to it. That is not a picture, that's just a montage that they have. But what you see here is that this service module is made by ESA. So Europe is already involved in the building of this hardware. So, it's a week ago the Europeans delivered a prototype of this service module to NASA, who will do tests now together with the Orion for on that part of the mission. So that is already a collaboration with Europe at least. This is a picture of the Curiosity, probably taken here on Earth, but then with an image from Mars. There, behind you see it's just this desert, and you cannot see a lot of, there's nothing green that is growing there. And that is a picture for InSight, is that this other lander that will arrive on Mars on the 26th or 28th of November. So it's still on their way to Mars. Now, what is the planning of this mission? Well, NASA has a planning in 3 phases. The first phase makes use of the International Space Station, and they will try to develop all the technologies that they don't have for the moment and that they need to before going to Mars. They will test that already on the ISS. So they're continuously experiments related to this mission to Mars. The second phase is going back to the moon and do their experiments, and there's one very special experiment that they do there. They will come back to that, a visit to an asteroid. And the return to the moon is between 2025 and 2030. So that's always problematic, and that can move quite quickly. So, but I think that it will be not, because 2020 is not so far away, and so they are surely not ready to do that in 2025. And then the third phase is going to Mars. First, where they have missions to the moon of Mars. Mars have 2 moons, 2 small moons, and so they will go there from 2035 to 2040. So that is all not so far away, and so we can really, I think that the first man that will set foot on Mars is now already somewhere on our planet. It's perhaps still a very small boy, but it's possible that yes, between us, I don't know if there are candidates here to go for that for 3 years, but it could be. And then the mission to Mars, a human mission, that will be such a long mission. They have the very nice poster that they have made with the 3 phases here, and they give here for the missions to ISS. Now normally the missions are 6 months. That they think to have, they will have missions for 12 months. They have it already once for 12 months on board for the ISS, and that's just in preparation for what the life support system can be, and to test this out. And that will be done also with commercial crew and commercial cargoes. If here on the Earth line the diagram, and so they have for return, if there is something going wrong, they can return to Earth in a number of hours. They have always on ISS 2 modules, Soyuz modules, Russian Soyuz modules that are always ready to come immediately back to the Earth. So if there's something really serious that is happening on ISS, in 4 or 5 minutes the astronauts can be back on the ground. So that is the safety that they have. If they have a mission to the moon, they will want also to have a mission of 12 months on the moon to prepare for the mission to Mars. But it takes to return at least 3 days to return from if something is going wrong. If they go to then the next step, and they go to Earth independent, then they have missions 2 to 3 years, and the return is always months. So it's not easy. If something doesn't work, they cannot immediately come back, because they always have this trip back that is quite long. Here you have again the 3 phases. What they are doing is they use the space station that will still be operational to 2024. And then they will develop the deep space systems for life support and human health. That are very important things that they have to know, have to control before they go to Mars. Something that they test now already, that is habitats. If they go to Mars, they need to have immediately habitats where the astronauts can live. And they think to have inflatable systems. And that is here the experiment that they have done from the firm Bigelow with an inflatable module. That is a picture taken in space. That was already a test that was done on board of the space station. And they will do soon another test. For proving ground, I would say that they will go, they have a special experiment there, and that is the ARMI, Asteroid Redirect Mission. What they will do is going with a robot to an asteroid, and they will pick up there a big boulder that is with a mass of 200 tons or something like that. But surely on asteroid that will not weigh so much. It will be possible to take that up and then bring it in an orbit around the moon. And then they will go with the Orion and land on this boulder and take samples and so on. So that is a specially oefening exercise to learn how to land on small planets and on asteroids. So that is a picture. Well, it's not a picture, it's probably a montage as well, and for such a boulder that they will bring in an orbit around the moon. I find that like somewhat science fiction that they can do that, but they really are ready to do that. That will be done in a couple of years or so. And then the Earth independent is really where they are independent from the Earth. That you will see, will show immediately what one of the reasons is that they are really independent. So if we have the constraints of the mission, well, first there is this minimum of 2.8 years. That is not easy. There's 7-8 months that they will be in microgravity. Then they have to stay a year and a half on Mars, where the gravity is only a third of what we have here. And we know now that astronauts can adapt themselves to live in 0G. We are, human beings, are the product of 3.5 billion years of evolution. And this 3.5 billion year has always happened in 1g, and this the gravity that we have on the Earth. So we are not built to live in 0g. If we go to 0g, we try to find out if the human body is adapting to this new system. So it is for quite some functions that it is that is adapting is going. Sometimes it takes till several months before it adapt. If you cardiovascular, it is taking 8 days. The vestibular is taking 24 hours, but there are other things that are taking a month and a half before they are adapted. And there are some things that happen, that can happen, that they don't adapt to it. And that's, for example, that's the calcium metabolism, so osteoporose. All the astronauts have osteoporose. That is, if they don't have medication of countermeasurements, they have osteoporose. And quite important is 1% calcium that they lose every month. So you can count that would be very, very dangerous as well. Fortunately, they have no medication, and with a lot of exercise that they do on board, that they can countermeasure this effect of the loss of calcium. So that is something that is a danger that they have to look at surely for the future. Radiation is also something that we're not adapting to it. It's so that all radiation that you get is cumulative. So you get it once, they come back, for example, the astronauts, when the second time, what they get as radiation is added to what they have the first time. So NASA, for all their astronauts, they take this in account, that the time that they are being in space, and that they have all dosimeters and the radiation that they have received, that they cannot go over the limit. So at a certain moment they say you cannot fly anymore because you have too much radiation up till now. So that are the two that are very difficult, that they still have to find something to avoid problems during the mission. Communication is also important. If the Mars is at the other side of the Sun as the Earth, then the communication, because of the distance, is 20 minutes before to have communication with the Earth. So it's very difficult to have a conversation with somebody if there are only always 20 minutes before you get the answer. So that is, therefore they say that the astronauts that go into Mars, they have to be independent. They cannot ask if something to be operational, they need immediately an answer. So that they cannot give in space around Mars, because there is 20 minutes before they get, sometimes it's 20 minutes before they get a response. The medical support is important, because see, if they stay for 3 years away, there's no doctor now, they can do all the exams that they want, that they can guarantee that somebody that is in good health now, that they will still be in good health in 3 years. That was told to me by the doctors, that is not possible that they can foresee that for 3 years. So they have to take care of that as well. So they will have need for medicine and so on. And if they don't take the medicine with them, they have to make it there on the spot as well. So that is quite something difficult that they have to take in mind. Life support system, water, oxygen and food. They have to assure that the astronaut has water, oxygen and food. There are projects already, and also in Europe is a project, and here in Belgium they contribute to that project, that's Melissa, where they try to recuperate urine and sweating, and so all the water that they have used, they recovered it and they reuse it. So they have really systems to reuse everything that is possible. That they do that already now on board of, they test this out on board of the ESS, but for Mars they will absolutely need that to do that. The water, they hope that they can find it. If they cannot find it, they will have to make it, and they can make it from the CO2. If CO2, if you have a reaction with hydrogen, you can become some water. That's what they have in well, like what they have in the fuel cells, where they make electricity that is now used even here for some cars, and so that they have fuel cells that here is oxygen and hydrogen that they let combine, and they get electricity and also water, so that they can know how to make the oxygen. They will have to take it also, or from the CO2, have a reaction to become oxygen with CO2, and they get oxygen and they get methane, CH4, and that methane, that is the fuel that they need to come back from the moon. They cannot bring all the fuel they need for the way back when they go, so they will have to make the fuel cell, and they know that they can do that with methane. The energy that they need. When the astronauts arrive there, they need immediately energy. So if there is no yet solar cells, they will have need of nuclear energy unit, or they have fuel from the CH4 they had made with the methane. They also can make some energy. Micrometeorites, that is surely on Mars. The probability is very small, but it exists as well. That there's some, like there is no atmosphere, there is much more meteorites that have impact in the Mars. And then takeoff or landing is always very difficult because there is no air, there is no atmosphere to drag to come back. And recently I saw that NASA is now trying out parachutes at 35 kilometer high to see if they can open parachutes with this small, with this low pressure. So they are also testing that. Another point is contamination. It's so that they can sterilize the experiments, all what that they want, all the instruments that they have sent to the moon, to Mars, that they are sterilized as much as they can. But they know that there's still thousands and thousands bacteria bacteria that can stay, that they cannot take away. That there are bacteria and microbes that can be very resistant, and they bring them to Mars. This was even a scientist. They asked it was asked, is there life on Mars? And he said, yes, there is life. All what we have brought. So if they go to Mars to find life, they might have to make sure that it's not the life that they have sent themselves. So that is a very important point, that it has to be very, very clean, maximum clean, everything that they send to Mars. So also for the people who are the astronauts who will go, will have to be in quarantine before the flight and in quarantine when they come back, usually for a long time. New technologies that they will have to do, I will just give here a list what they are doing. It is important protection against the radiation, that is essential that they can do that. And they are looking for new materials, nanotubes, and so that they think that they can absorb this very heavy particles that coming from galactic particles and so on. Now, still some words of the crew. It's so that it's a project that they hardly can do it on their own. NASA can do on their own. And Apollo, it was NASA who did it completely. Now they will need help from other countries. That means that it will be anyway, if they have a crew, it will be a crew composed of different people from different lands, so have different education, culture, religion, self, and probably different gender also. It is for the moment it's no more possible to have such a mission that put only men on board. It will be men and women, so that is for sure. And that's an adult thing that they have to take in account. Constraints are that they have microgravity during the launch, microgravity to come back, and when they are on Mars, they have the third of the gravity that they have here. They know that we can live in 0G, that we have live on 1G, but what happened when it's only a third, that they don't know. They have to find that out as well. The confinement is also very important, that they are so in a close environment, always with the same people. That is a very difficult situation. And then the isolation that they have with their relatives here on Earth. It's not so that they can make a phone call to their relatives just with the system with a delay of 20 minutes. That is just not possible. And at the end, the long duration space travel can have detrimental effects on the human physiology. So things that they still don't know, but that surely can happen during the 3 years that they are there. So there are all problems that they have to solve. What they think to go with a crew of 2, that is too small. That will not be possible. 4 is still small. 6 is perhaps already acceptable for a first mission, but probably they will have to do 2 missions together with 2 Orions, so that they have somewhat more people. If you have the functions are different than what they have now, what they had for the Apollos, what they have for the shuttle, for the ISS. They will still need other people. Mostly probably mechanical engineers and so that can fix everything, and what they have also, they will have some information, some capabilities for us biochemists as well. You have so many disciplines that you will need, that each astronaut will have to bring at least two. A doctor will also have to be biochemist, and an engineer have to be geologist, and so on. The physical, what they can ask as physical requirement for the astronauts, it's somewhat related, somewhat the same as what they ask now for space for astronauts, because they know enough, and they don't like to go higher than that and exclude other people. So what is more important is surely the psychology of the people, and so they will be tested very, very well and in team. And then if they have food on Mars, well, they will not have cows and pigs there. They will have, they can grow plants, and so they will have to be vegetarian. And that is also a problem, because they need a lot of energy, a lot of food, and how they will do that. Probably they will find something to change that, but that is also necessary. So that is a picture how it can look like a station on Mars. You see here in the caves under the ground that they grow the food, all vegetables, with artificial light. They cannot have just, let's say, glass or something over it. That's because resist the radiation, so that would not help. So they have solar panels, they have probably a nuclear central as well. So we have to build all this in the infrastructure. You will have the factories to make the water, the oxygen, and the methane to come back. You have the rocket to come back. So that is, and here the astronaut with a special spacesuit that is resistant to the radiation. So that is something for the future with all the problems that they still have to follow up and find a solution for it. And then this is then a poster that's probably not yet, you're not seen now at the moment yet, but probably the children also not yet. It's more for the grandchildren that perhaps someday they will see in their universities have posters like that. For your holidays, go on Mars, the best way to have fun for all the family, so that a family trip to Mars, someday it will be possible, but no, not yet, but it is coming. So I thank you for your